Okay, gamma radiation and a radiation summary. Gamma radiation is actually quite an easy one to understand. It doesn't do much really. So gamma rays are an electromagnetic wave. They're the same family as radio waves, microwaves, visible light, infrared, ultraviolet, X-rays and gamma rays. They're very energetic, they travel at the speed of light, and they're weakly ionizing. Ionizing means that it will knock off electrons off an atom, and if you knock off the electrons of an atom, it will then combine with another substance that perhaps you don't want it to, and so it can cause cancers and the like. On the whole, gamma will actually go through the body. It doesn't matter if it's inside or outside the body. There is a chance it will ionize, so you've got to treat it with respect still, but on the whole it will just simply go through your body. You need to know how the different types of radiation are affected by electric fields. An electric field is generated by, if you have like two steel plates or flat surfaces, and on one of them you attach it to a negative terminal of a power pack, and the other end you attach it to a positive terminal of a power pack, put a really high voltage between it. If you then fire different types of radiation through it, what you find is that the gamma rays are unaffected by it. They are, because it's an electromagnetic wave, it is not affected by electric fields. However, the beta particle, which has a negative charge, is attracted to the positive plates, and alpha particles, which has a positive charge, is attracted to the negative plate. So beta and alpha go in opposite directions because they've got charges, whereas gamma does not have a charge. And in a magnetic field, again, gamma is unaffected, but alpha and beta go into circular patterns, again demonstrating that they have got charges. You need to know about how far different particles, radiations go through different substances. So alpha is stopped by paper, beta goes through paper but stopped by aluminium, and gamma goes through the whole lot. And thicknesses of lead and thick concrete will cut it down significantly, but some still gets through. The formula is dead easy. On the whole, when you release a gamma radiation, you don't affect the proton number, you don't affect the mass number, because it's not actually a particle as such with mass. So there you go, that's what actually happens. And the key words is you need to know it's an electromagnetic wave, it's got no mass, it is penetrative, it will go through practically anything. It is ionizing but less than alpha and beta. I need to know that it is unaffected by magnetic fields. There you go. Oh, by the way, gamma radiations tend to be emitted when an atom is unstable because it's got an unusual shape to it, and it's just simply finding a way of releasing energy. So you tend to find out that whenever you give off alpha radiation and beta radiation, you always give off a little bit of gamma radiation at the same time. There we go. That is a gamma radiation and a radiation.